Okay, in this video I'm going to show you how to solve the index equations that we find on the screen right now. So the ones in blue are quite straightforward. There's no need to use logarithms for those. And the ones underneath in green, we will need to use logarithms for them. Okay, let's get started. So the first one. 2 to the power of x is equal to 32. So no need to use a calculator, no need to use logarithms for this one, because we know that 2 to the power of 5 is equal to 32. So the solution to that is x is equal to 5. Okay, the second one. A little bit more complicated. I can't think of a number that straight away that works for that. However, if I change 1 over 27 as a power of 3, then that's going to make that a lot easier. So I know that 27 is equal to 3 to the power of 3. So 1 over 27 is going to be 3 to the power of negative 3. So I'm going to rewrite that equation. 3 to the x plus 1 is equal to 3 to the power of minus 3. Now, because we've got the same base, that means that our power here, our indices must be equal. So x plus 1 must be equal to negative 3, so x is negative 4. Okay, the next one's not quite so obvious. And the reason for that is that these two numbers here are not the same. But if we can change these powers so that they are the same, then we should be able to solve that. So let's think about a number that if we raise it to a certain power will give us 32. So 2 to the 5 gives us 32. That's handy because 8 is also 2 to the power of a number, 2 to the power of 3. So we can write both of these numbers here as powers of 2. So let's just rewrite that. 2 to the 5 is 32. And 8 is 2 to the power of 3. Now what we know about indices is that we need to multiply these two powers together. So that's 2 to the power of 5x is equal to 2 to the power of 3. And since these two bases are now the same, we've got 5x is equal to 3, and therefore x is equal to 3 divided by 5. So there we go, we've solved our first three equations. No need to use logs at all. Right, what about this next one? Well, I can't think of a value of x for which I can raise 2 to be 50. I know that 2 to the power of 5 is 32. I know that 2 to the power of 6 is 64. So the answer to this, the value of x, must be somewhere between 5 and 6. But it's not so obvious how we do it. So to solve this type of equation, what we're going to have to do is use logarithms. So let's just remind ourselves a little bit about that with our definition of what a logarithm is. So just remember that a logarithm is just another way of writing an exponent. So in this example here, x is equal to a to the power of y. Another way of saying that is that y is the logarithm of x base a. A to the power of y is x, so y is logarithm of x base a. And similarly with this one, I can rewrite this exponent as a log. So y in this case is going to be the log of x base e. And the log of x base e, we sometimes call the natural log of x, and we can write as ln of x. But when we see ln of x, we know that that's what this means. Log of x base e. So that's just a reminder of logs. We also know a little bit about our log laws. So just to remind you of that, if we add two logs with the same base, then we can find that quickly by multiplying the two numbers together and finding the log of that. Similarly, for subtracting two logs, we're going to divide those two numbers, and then this last one here is going to come in very useful for what we're about to do. So the log of a number x to a power is exactly the same as n lots of the log of x. And that's going to be really helpful for our questions. So what we want to solve is 2 to the power of x equals 50. And as I just said, x has got to be somewhere between 5 and 6. So what we're going to do for this question is we're going to take logs of both sides of this equation. Now we can use any base at all here, but it would be helpful if we used a base that perhaps we've got on our calculator. So for this one I'm going to choose log base 10. So I'm going to take log of base 10 of both sides of this equation. And that makes sense for us to do. That's perfectly fine. What we've got on the left hand side of the equation here is a number. What we've got on the right hand side of the equation is a number that is the same. So it makes sense that the logs of those two numbers that are equal must be the same as each other. Now then, we can see straight away here how we're going to use this log law, because log of 2 to the x we can write as x log of 2. And what is log 2? Well, it's just a number. We can work it out on our calculator. In fact, just pause the video and see if you can do that now. Okay, so on your calculator there, log base 10 is the log key here that just says log. When we don't see the number 10 by it, it means log base 10. So if we want to find log 2, we just type in log 2. And that's just a number, isn't it? So we've got this number here that when we times by x is going to give us another log. So all we're going to do is we're going to rearrange this equation so that we have x on its own. So a number times x is equal to another log, which is just another number. So what we're going to do is we're going to divide both sides of this equation by that number log 2. Okay, so on our calculator we're going to work out log of 50 divided by log of 2. Just worth mentioning at this stage here, this might look familiar to one of the log laws that we've seen. We seem to have a log over another log, which looks familiar to something that's higher up the page. This here, but it's not. Okay, here we've got the log of a number over another number, which is what we get when we subtract two logs. That's not quite the same thing. So that's easy to get caught out with that. But we haven't got a rule for dividing by logs. Okay, so on your calculator then, you're just going to work out the log of 50 and then you're going to divide it by the log of 2. Okay, so if we type that in our calculator, we should get an answer of 5.64 to 3 significant figures. And that makes sense because if you remember at the start, I thought my answer was going to be between 5 and 6. Since 2 to the power of 5 is 32, 2 to the power of 6 is 64. I knew it was going to be somewhere in between those, so my value for x needed to be somewhere in between 5 and 6. That makes sense. And what we've just done there is the principle, or that method is the principal method that we're going to use for solving the rest of these equations here. All we've got is equations that are slightly more complicated, and the rearrangements that we're going to do thereafter is going to be a little bit more challenging. But the principle is the same thing. We take logs of both sides and then we rearrange those equations. So let's have a go at the second one. Actually, just before we do the next equation, I took log of base 10 for this question here. There's no reason why I couldn't have taken a log of a different base. And I just want to demonstrate that that's the case for you. So let's just do the same question again, but with a different base. So 2 to the x is equal to 50 was the equation we're solving. If I take log of base e, which remember we can write as ln for that, then we've got a similar looking equation, and we've got that property again. Log of 2 to the x is the same as x lots of log 2, and that enables us to rearrange this equation, divide this time through by the natural log of 2, or log of 2 base e, to give us the natural log of 50 divided by the natural log of 2. Okay, so we've got exactly the same equation to work out here, but this time it's base e. So let's just check that that works out. So there we have still on the screen the last answer. Let's just try that with log of 50 divided by the log of 2, and that answer is exactly the same. So it doesn't matter at all what base you use for those logs, and I could use any base at all. The Casio calculator is very good, and it has lots of different bases on it for our logs. Let's go and find another one. This one here, I could work out log base 85. Let's do something silly like that. Log base 85 of 50, and if I divide by the log of, let's go back there, the log of 2 base 85, struggling to type these in, then it should give me exactly the same number. Okay, so it doesn't matter what base you choose. Is it base 10? Is it base E? Is it base 85, or any number you want? It will always give you the same answer. Okay, back to our next example. So 5 to the x is equal to 2 to the power of x plus 1. And we're going to use exactly the same method. We're going to take logs of both sides. Okay, so I'm going to go for log base 10. Now, with log base 10, as I saw with the calculator, if we just write log, we're assuming that's what we mean, log base 10. So I'm just going to save myself a couple of seconds, and I'm not actually going to write the 10 in there. And we all understand that from now on, that means log base 10. Okay, so just taking logs of both sides, and I'm now going to use that third log law again, and this is the one that's going to enable me to transform this into an equation we can solve for x. So log of 5x is the same as x log of 5, and log of 2 to the power of x plus 1 is x plus 1 lots of log 2. So what we've got here is another equation to solve, although it's a little bit more complicated, this one. But in our head, we're just thinking, this here, log 2, it's a number. So we've got a number times by x plus 1 here, and another number times by x. All right, so we're just going to try and solve an equation here. And this equation, the unknown is x. That's the thing we're trying to find out. Normally, when we solve that type of equation, we gather the x's on one side and solve it like that. Well, this is no different. Okay, it just looks a bit more scary because instead of a number, a whole number even perhaps, we've got log 2. Right, so to help me with this, what I'm going to do is I'm going to multiply out the brackets here. So x plus 1 lots of log 2 is x log 2, and 1 lot of log 2. So I'll just write that as log 2. And now I can see that I've got two parts of this equation with x in them, and I'm going to gather on one side. So I'm going to leave my log 2 over here, and I'm going to subtract x log 2 from both sides of the equation. So x log 5 subtract x log 2 is equal to log 2. And then what I need to do to be able to solve this equation here is just factorize that. So both of these expressions here have got an x in them. So if x is my common factor, then inside the brackets I've got log 5 subtract log 2. And that just means that I've got x times this number, whatever it is equal to log 2. So if I want to work out what x is, I need to divide by this number here. So my answer is going to be log 2 divided by log 5 subtract log 2. And that's great. Now there is something that I can do with this, because log 5 subtract log 2 from our second law here is going to be log 5 over 2. So I could write that, if I wanted to, as log 2 divided by log 5 over 2. And I could leave my answer like that if I wanted to, or could type that into the calculator. You just try that now. Pause the video, type it in, and then I'll show you my answer in a second when you can compare. Okay, so back again. If you type that in carefully, the fraction button is really helpful on your calculator for making sure that you type that in right. So log 2 divided by log 5 over 2, the answer that I get for that is approximately 0.756. So hopefully you got the same answer. Okay, one more question to do then, and this one has got e in it, so that's question 6 I started with. E to the power of 2x is equal to 4 to the power of x plus 1. Now there's nothing I can do to manipulate those to make them have the same bases, so I'm going to need to use logs. Now then, I'm just tempted, because I've got base e here, when I take logs of both sides, to use e as my base. So that's going to be log, I'm going to take log base e of both sides, or as we're going to write that, ln of x. So the log of e to the 2x is equal to the log of 4 to the x plus 1. And so we've got, let's use our rule again here. That third law, the power law, this is the one that's most useful for all of these. So log of e to the 2x is 2x log of e, and here same again, I've got x plus 1 lots of log of 4. Now then, there's something interesting here, because I've got log of e. So what does log of e mean? Well, log of e, remember that's natural log of e, so that's log to the base e of e. Well, that's got to be 1, hasn't it? E to the power of 1 is e. So that number there is actually 1. So actually we've got a really quite a simple equation in the end, or we've just simplified it at least. So we've got 2 to the x time, or 2x times 1, and on the other side I've got this. Let's expand the brackets as we did before. And let's gather the x's on one side. So I've got x's here and x's here. Let's leave this number here and take the x's onto the left hand side. So I'm going to subtract by this number here. 2x subtract x log 4. And what I've got left is log of 4. And then just as before, let's factorize. Common factor of x here. Take an x outside. 2 subtract log 4 is equal to log 4. Let's divide through this by this now, and I'm left with log 4 divided by 2 minus log of 4. Now in some questions you might be required to leave it in terms of a log. In other questions you might be required to work out what that is as a decimal. So let's just imagine we're asked to work out what it is a decimal. Get your calculator out, type that one in, pause the video now and I'll come back and I'll show you my answer. Okay, how do you get on with that? I've got an answer of 2.26 to 3 significant figures. So hopefully you got the similar one. Okay, and that's basically it. We're solving then exponential equations. Starting off with some simple ones where we don't need to use logarithms. We're just trying to transform the information into an index equation that we can solve. But then when we can't use that method, then we're going to need to take logs of both sides. Okay, that's 20 minutes of video. I think it's time for you to have a go at some simple questions for yourself. So here we go, have a go at those, and we'll check the answers at another time.